Okay. We talk about paper 5 today. Today will be the last class. If I have more things to tell you about paper 5, then I'll just record videos and send to you. Okay. Today I'll focus on drawing the diagrams in paper 5. And also I'll give you a compilation of all the safety and precaution questions that they will give in paper 5. Then the rest more specific one on certain types of experiments, I'll do separate recordings and send to you. Okay, so drawing experimental setup is actually quite common in this paper 5 because paper 5 is actually written practical paper. Don't have to enter the lab to do practicals anymore, but they want you to know the way to do the experiment, okay, the hypothesis, what kind of variables that you are setting in the experiment, what kind of setup that you're using, and every single step, like, why do you do certain things? They hope that you know all this very well. So practicing this paper 5 is becoming very important because I feel that they actually always repeating the same questions. So if you do more, then you will know how to answer most of them. Right. Now, drawing experimental setup, okay, I analyzed the questions from summer 14 until winter 21. Now, the reason why I started from summer 14 is because before summer 14, okay, most questions were essay type. Okay, very difficult. So I think because students always get very low marks in this essay type of questions, they have decided to change the format and started from summer 14, the questions become more guided. Shorter part, shorter answers required. So I think students can score better. So they keep the format until now. So if you have time, okay, to do more paper 5, you start from winter 21. So you go back, okay, if you have time, you do until summer 14, then stop. You don't have to go even earlier, okay? Now, so I analyzed the question from summer 14 until winter 21, 7 years. I realized that the type of diagrams they will ask is these 8 types. So if you can master these 8 types, then whatever diagram that can come out, then you know how to draw them. Now, first type is collection of gas. So reactions that involve production of gas, then questions say, oh, I include in your setup to collect this gas. Okay, so what should you draw? Then you have separate chemicals before experiment, filtration, enthalpy change, mass loss, electrolysis. Number 6 is actually electrochemistry. 7 is to control the temperature in the experiment. And number 8, experiments involving condenser. Right, only these 8 types. So you go to the first one, collection of gas. So sometimes you have to draw the whole thing. Sometimes they ask you to complete a diagram for collection of products, and the product is a gas. So you can choose to use the one on the left-hand side or the one on the right-hand side, depending on which one you like, because both they can accept. Some of my students, they prefer this one. Okay. Some they will just draw this one because they don't have draw the water. So it's just a personal preference because both can be accepted. But I want to tell you what do you need to pay attention when you draw them. Okay, whichever one of them. So if you draw the one on the left-hand side, okay, measuring cylinder, then you will have to make sure this part, okay, from whatever reaction vessel that you use, this case is a conical flask, but some other question they can use other types of vessel. Okay, I don't care what is that, but make sure that you seal from the delivery tube. Okay, because you don't want any gas to escape. You want all molecules of gas to enter only here. so that you get very accurate volume of products form. Okay, so this part important. Let's just put tick here. And then, okay, this is inverted. Then you have water. And you have to include the capacity of the measuring apparatus that you're using. So in this case, measuring cylinder, if you're using 100 centimeter cube, then you write 100. If you know that the gas that is going to form is more than 100, then you probably have to suggest 250. The sizes of these glasswares, these apparatus in the lab, the quite standard one. Okay, always start from 5, then 10, then after 10 you have 25, you have 50, 100. After 100 it will be 250. Okay, then the 500, after 1000. Although you have not used very big one like 500 and 1000, but they actually consider very common. The lab assistants, okay, lab technician, we have used them more often than you, because you are doing experiment, normally we'll give you the smaller one. So whatever apparatus measuring cylinder, beaker, volumetric flask, they all follow this order one. Okay, the size from the smallest one until the biggest one. They are bigger than 1000, 2000, 5000. Okay, that means 5 liter. We have them in the lab, but we don't show you, okay, because you are not using it. Okay, so write down the capacity. So if you choose to use the right hand side one, so again, you see sealing is very important. Make sure no gas can escape. And of course, write the capacity. If you're using 100 centimeter cube, then you write 100 centimeter cube. Oh, and also this part. So if you use gas syringe, you have to seal 2 parts. If you use measuring cylinder, then only one. Okay, this one. Now the next time I put in, you see a same type of picture. This one I actually found it in one of the past year paper 5. So I copy in the diagrams. Okay, then you know, oh, okay, if I follow this, since they can appear in the paper, okay, then these are the correct one. I should remove this one. Okay, but very similar. Okay,